Hello, in this session I'm going to talk to you a little bit about teaching fractions, developing strong conceptual understanding of working with fractions. So we know that learners who come up to the intermediate phase or grades 4, 5, 6, 7 often have a problem with working with fractions. They don't understand it on a conceptual level. And here you can see, somebody answering this problem has said it means 4 is a numerator and 5 is a decimal fractions. And then they've said 4/5 it means a number that has been shaded. So clearly they do not have an understanding of what they're working with here. They can see the symbolic representation, but they don't understand it mathematically. They haven't been taken through the process where they've built up a strong conceptual base of what it means, what 4/5 mean. Okay, so let's go back. So in this session, I'm going to be focusing on learners who are at the concrete operational level, if we're thinking about Piaget. So end of grade 1, grade 2. So prior to this, learners come into school with some knowledge of fractions. They have been sharing, they have been engaged in play where they've needed to know, okay, let's be fair and share things amongst each other, okay? But now they are developing a sense of the idea of conservation, that when you separate, for example, a shape into parts, that it relates back to the whole. So if you have 8 pieces, 8 equal pieces called eighths, if you put them all together again, you get one whole piece, okay? So that relates to the idea of conservation and reversibility. And you can look into that a little bit more if you look up Piaget and his stages of development. So when you are developing a child's understanding of a concept, you need to have a clear understanding of where you want them to get to. So if you're looking at their learning pathway, what is your goal? Whether it's where you want them to be at the end of the year, whether it is where you want them to be at the end of the lesson, you need to have a goal in mind. And then ideally, you work backwards from that point to see where you need to get them to and how you're going to do that. A clear idea of progression, scaffolding, takes you back to constructivism and Vygotsky, working in the zone of proximal development. And you have to have an understanding that although as teachers, we often track the learning pathway as being linear in a line, just so that we can have an idea, it's not always linear because you're going back. You're going backwards, back to the concept again, revisiting it, discussing it, scaffolding. So it's not always a linear process when you're teaching. And the same goes for, when you're teaching fractions. So let's have a look. What do learners come in with? What do they know by the time they get to sort of grade 1, grade 2? Well, they've had experience with part-whole relationships, problem solving with remainders. What do we do with the leftovers, sharing and grouping? And I like to say smashing numbers so that numbers can be broken up. They know you can make collections of things. And so they've got this physical knowledge, which is developed through interaction with concrete apparatus. And now we're going to develop their social knowledge. So social knowledge is knowledge that you can only acquire if it's told to you. So they may know that you could share something with 4 people by dividing it into 4 equal pieces, but they might not know that those pieces are called quarters. And those are the things that we're working on with them alongside the whole conceptual development of what fractions are. So the big ideas when you're teaching fractions, dividing equal shares. It's all about equal pieces. Okay, you can divide things into unequal pieces, but that's not necessarily what we're dealing with here when we're talking about fractions. So it's about equality, equal pieces of a whole. And remember that often when we are teaching fractions, we tend to stick with an object like a pizza or a shape or a piece of chocolate. And we forget that there are 2 kinds of wholes. There are collections of objects, so sharing out a packet of sweets between 2 people, and then sharing an object between 2 people. And it takes a different kind of understanding, and it takes time to work with both kinds of wholes for the learners to become comfortable with that. So we need to keep that in mind. So if we're dealing with fractions with the whole as an object, don't go and use pre-partitioned objects. Don't go and buy, those wonderful circles that have been divided into equal pieces. Allow the learners to create their fractional parts. That is a very important part of the developmental process in this. Okay, so although we are inclined to go straight to let's cut up a piece of A4 and just say how many pieces do I have and what this piece is called, we actually need to introduce the concept of fraction through the purposeful problem solving. So there was a traditional way of introducing it, but now we know, research has shown that it's better to start from a place of problem solving where you are eliciting informal knowledge from the children, and that means that you need to be purposeful with the kinds of problems that you pose. Don't introduce symbols yet. That is a real no-no, okay? Children in the foundation phase can still learn a lot about fractions without being weighed down by the symbolic representation. They need to develop their conceptual understanding first, and the language and vocab takes priority. So you can still talk about quarters, and you can work with quarters and fifths and twelfths and all of those things. But there's no need to introduce symbols yet. So please don't. Wait a bit. So now that we're talking about the whole idea of introducing fractions through problem solving, which one of these problems do you think would be good to start with? 3 dogs and 6 biscuits, 3 dogs and 4 biscuits, 3 dogs and 2 biscuits. Now think about what you're trying to elicit. You're trying to introduce the idea of sharing something so there are no remainders, and there needs to be a fractional part involved in that. So 3 dogs and 6 biscuits, would that give you a fraction? No, because you can share that equally and you don't need to break anything into into fractional parts. What about 3 dogs and 2 biscuits? Now that's a challenging one because children are used to saying 1 for you, 1 for you, 1 for you, and then, cutting up the leftovers. But if you begin with a situation where you don't have enough to start with, it might cause them a bit of anxiety. So I wouldn't go with that one. I would start with 3 dogs and 4 biscuits because they each get 1. Now, what do we do with that remainder? How do we make it fair? Okay, so I would suggest that a problem like this, where you've got more than enough to share, would be good. So let's have a look at that. So here we go. We've got a problem. Share 4 chocolate bars equally amongst 3 friends. This is a good assessment tool so that you can figure out where the learner is at, what they do know and what they don't know yet. The learner says each one gets 1.5, and the interviewer says, show me. And he says, this one gets 1, this one gets 1, this one gets 1, this one gets 1, and then break it in half, and they must break it in 2 sides. So the image, the picture they've drawn actually shows quite a good understanding of equality and breaking something up, but they don't have the social knowledge yet. They don't understand that that is called, each piece is a quarter, and you've got 4 quarters, they each get 1.25. And that's where you are going to guide them as teachers and explain that and have them work with this kind of problem more than once so that they can then develop a flexibility with working with problems like this. Okay. So often when you are asking a learner to share their strategies, the things they say will be very telling, and you know then what they understand and what they don't understand yet and where you need to guide them. Here again is just another example. You can see the problem is 3 children, 4 chocolates. And I actually like the fact that we haven't started with halving because we often go straight to halving. So we say 2 children, 3 chocolates. And children get stuck on a half. Everything becomes about being half, half, half. And if we just limit them to that, we start with that every time, it just solidifies that. So why not have 6 children and 7 chocolates? You can introduce 6s and 7s and 8s and 9s straight away through problem solving. And just to remind you of the importance of language and that fractions come about because of dividing. So you need to be aware of the kind of language and vocab that you're using. To use the term dividing as well as sharing and grouping, okay, as you're working alongside the children and explaining things to them. So here we go, talking about a supportive classroom culture. Okay, so problem solving has an element of risk in it, but if you facilitate it in a way that promotes discussion and children don't feel afraid of taking risks, then the misconceptions are identified and resolved. You can interact and reflect on them, and they are able to construct and share their own strategies, and then they gradually develop more powerful strategies. And as the teacher models the correct strategies as well, okay? So modeling is equally as important. And let's have a look. So when you're teaching about fractions as an object as opposed to collections, don't restrict to one shape or context. So here you can see I've done fractions, 8s in a circle, 8s in a rectangle. How does it look different? You need to allow them to play with this idea of the fact that the corresponding, here you go, I think it's in the next one, yes. The number of fractional parts are named according to how many parts there are, but you can get fifths that are smaller and fifths that are bigger depending on how big the whole is. If you have a very big cake and you divide it into fifths, and then you have a very little cake and you divide it into fifths, they're still fifths because they're equal shares, 5 equal shares, but they look different. So they need to get that flexibility and understanding. Okay, and that means you need to give them lots of opportunities to create fractional parts, different shapes, different fractional parts. Okay.
Hello, we are in the Italian kitchen. We are making pizza to learn about fractions. Hey, very exciting. Here we have our musician. Oh, he's playing his music. Oh, what a pizza are you making?
I'm making macaroni and cheese.
Oh, a macaroni and cheese on a pizza. Very interesting. Thank you. Hello, we are in.
Music on.
Hello, we are in the Italian kitchen. We are making pizza to.
So an idea you could use when you are introducing this kind of thing is you could use, I often give the children a paper plate, or not even a paper plate, but a circle that is represents a plate that is the same size as their pretend pizza, so that it's a reference point when you're cutting. So I often start with something like, I went to the Panarottis and I was going to have a whole pizza, but I'd already had a snack before I arrived, and I decided, oh my word, I could never finish a whole pizza, but I could finish 2 halves. Yep, 2 halves. And what happens, do you think? Well, the children all yell, it's the same, it's the same. And then you continue on and you keep cutting and you keep saying that you couldn't manage to eat 1 half, but you could manage to eat 2 quarters. And what are you developing there? What are you developing there? You're developing the idea of equivalence, that 1 half is equivalent to 2 quarters. It would also be equivalent to 4/8 and such and such. Okay, so you're giving them that idea. And here's an example of one of the pizzas that Lerna made, and you ask questions as you're busy going. So you ask them things like, how many pieces do you need to make 1 whole pizza? If you've cut it into 8s, you need 8 8s to make 1 whole pizza. How many pieces do you need to make half a pizza? Oh, you need 4 8s. So you ask purposeful questions all the time. So in other words, so Sarah or Sarah, would you prefer 2 quarters or 1 half of the cake? That's again another purposeful question to elicit the understanding of equivalence. Okay. And what about this one? Would you like an 1/8 of a chocolate or a 1/6 of a chocolate? I'm sure you'll realize that because of the way that an 1/8 is written and their knowledge of numbers and whole numbers, they may think that an 1/8 is actually bigger than a 1/6. And therefore, you need to give them the opportunity to explore this idea. Okay, and you need to show them and model and explain why is an 1/8 smaller. If you have more people at your birthday party and you have to share your cake between more people, the pieces will be smaller. So you need to keep on going, keep on revisiting these concepts. And here are just some ideas for purposeful preparation. So when you're teaching fractions, you need to know what you're going to ask. So once you've been teaching for a few years, you're kind of used to the kind of questions, but certainly when you first start out, you need to think about what you're asking so that it makes them pick up on the concepts they need to develop. Okay, are all your pieces the same? In other words, are they all the same size? Remember, a shape can be divided into any equal number. You can go to 7ths, 14ths, 10ths, any of those. You mustn't just stick with half and quarter and thirds. Eat 1/8, how many 8ths are left? So it's the kind of thing you're going to be asking all the time while you're working with them. Now, just briefly, let's talk about fractions with whole as a collection. Let's have a think about how we could introduce this using a 4 squares chord. So if you think about your class, I don't know how many kids you have in your class, possibly the number of kids will not divide by 4. So that is a challenge, but it's worth discussing. What I like to say to them is, come on, I'm going to go and divide you into quarters. And they usually say, oh no, don't cut me in 4 pieces. And I say, no. Let's think about this. How can we divide our class into 4 equal collections, 4 equal groups? And then they problem solve and they work it out. And if there's extra kids, you talk about how that could work out. But it's just really nice to work from a place of using the children, using the things that they know, and making them an active participant in their learning. And then there's so much we can say about this, but this is one of the ways that I teach dividing a collection. So I'd say, okay, we're dividing into fifths. So how many groups are we needing? We're needing 5 groups. And then they sometimes would draw the groups and then share them out. Okay, so there are many ways to introduce fractions, to discuss fractions with learners, but we need to be careful that we are not exposing them to the symbolic notation first, that we are actually giving them the opportunity to develop a strong conceptual understanding of fractions. Bye.